Hello everyone, and welcome to the Introduction to Natural Language Processing lecture. While there's no official reading assignment, if you would like, I would suggest reading the Wikipedia article on natural language processing to get some context for this lecture. However, you don't have to read the whole article, just go ahead and browse through it. Let's talk about natural language processing and why you may want to use it. Natural language processing, or NLP, serves a lot of use cases when you're dealing with text or unstructured text data. Imagine you work for Google News and you want to group news articles by topic. Or maybe you work for a legal firm and you need to sift through thousands of pages of legal documents to find the relevant ones. This is where natural language processing can help. We will want to compile the documents in some fashion, get features from them, so we'll have to featureize those documents, and then compare their features. Let's go through a simple example. Imagine you have two very simple documents. In this case, the document is just blue house, and then the second document is red house. That means this is just a document of basically a single sentence. So the first sentence is blue house, that's document 1. Second sentence, red house, is document 2. A simple way to featureize text documents is to featureize based off of word count. So we transform blue house into a vectorized word count. We basically create a vector count of all the possible words throughout all the documents. In this case, they're red, blue, and house. And then we just count how many times those words occur in each document. That means in this case, for document 1, blue house, we get 0, 1, 1. Since red occurs 0 times, blue occurs once, and house occurs once. Similarly, for red house, we get 1, 0, 1, because red occurs once, blue 0 times, and house 1 time. A document represented as a vector of word counts is called a bag of words. And hopefully you saw that bag of words in the Wikipedia article if you decided to read up on it. Once we have these bag of words vectors, you can use cosine similarity on the vectors to determine similarity of the documents themselves. This is really useful because we're basically treating each document as a vector of features, meaning we can perform mathematical operations such as the cosine similarity, taking their dot products and then dividing it by the multiplication of their magnitudes, or other similarity metrics in order to figure out how similar two text documents are to each other. We can improve on bag of words by adjusting word counts based on their frequency in the corpus, and the corpus just stands for the group of all the documents. We can use something called TF-IDF, or term frequency inverse document frequency, to do this. Let's go over some definitions. Term frequency is the importance of the term within that document. So we'll denote TF, term frequency, as a function taking in D and T, where the number of occurrences of term T in document D. Then we have the inverse document frequency, which is the importance of the term in the corpus itself, so all the documents. We'll call that IDF of T equals log of capital D divided by lowercase t, where capital D is the total number of documents, and lowercase t is equal to the number of documents with the term. Mathematically, then we can express TF IDF as the following equation. Here, we're saying term x within document y. So we can say TF x comma y is the frequency of x in y, and then we multiply that by the log of the total number of documents divided by the number of documents containing x. The reason we do this is so that we can get not just a word count, but also some sort of notation on how important a word is, not just relevant to the document, but to the entire corpus of all the documents. Now that we've gone over the theoretical background behind natural language processing, we can begin to discuss how we're going to use Python to do natural language processing. Before we get started, however, we'll need to download an additional library. Go ahead and go to your terminal or command line and use conda install nltk or pip install nltk, depending on what distribution of Python you're using. The nltk library or package is going to allow us to work with natural language or text data very easily. Once you have that package installed, we'll go ahead and start our example by building a spam filter with Python. Then, your portfolio project will have you working with real data from Yelp, an online review site. Okay, Thanks everyone, and I'll see you at the next lecture.